The next thing that I'm going to talk about is packages in R. This is where a lot of the power of R really comes through, although I think you can do a lot with just the base R installation. I hope I've driven the point home that R contains that the stuff that R comes with that allows you to manipulate data types and perform operations that you want to do take the form of named objects. For example, functions and variables, and many of them are available in R by default. So we learned, for example, about the square root function early on in this workshop that has a name, sqrt, and it calls a more primitive function, but that's not the point here. The point is that that function is available in base R and it has a name, and there's other things like the variable pi that are available um, by default, and all of the other built-in functions that we've learned about so far. But one of the real strengths of R is that it's free and open source, and so it's easy to write new packages containing new functions. And many of those are available online, and many of them are vetted. So the Comprehensive R Archive Network hosts many such packages. They've been tested to make sure they work properly in general. And you can download them and then load them into any R session that you're working on. And that's one of the reasons why R tends to be capable of performing a lot of state-of-the-art statistical operations because people make code available for free to do those operations. Um, when you load a package into your R session, its functions and variables become available to you as named objects, just like the named objects that are available by default, like the square root function or the pi variable, or the mtcars data frame, for example, that we've also worked with a little bit. And the package name itself will show up in the vector of locations where R is searching for names of objects. So currently, I alluded to this before by mentioning that these are all the base packages and that this is the data frame that we have currently attached. So I'm going to start off with an example based from the car package, which is one package that I think has a couple of very useful functions. One of which is called recode. So this word recode is not an object by default. Object not found if I try and just run that line of code by itself. Um, but it happens to be the name of a function in a package called car, C-A-R. So the first thing to do to get that function would be to install the car package. And like my comment says here, how to install a package may depend on your platform. You could always try running this line of code, install.packages, and then the name car in quotation marks indicating that it's a string. I already have it installed on my computer. And once it's already installed, then you can load it anytime. So it's not currently available in my R session, but if I run library with the argument car, library is a function that takes as its argument the name of an installed package. And what it did is it added the package car to the beginning of the vector of locations R searches for named objects. After the global environment, of course, the global environment always comes first. And now the recode function exists. Normally, you wouldn't look at the code of a function by just calling the function's name at the console, but you can sometimes. Anyway, the function exists, and here's one example of how to use it. Let's say I wanted to change my race variable to numbers for some reason instead of strings as the indicators. Um, I could use the recode function, specify that the input is going to be the existing race variable, which is this factor right here. And I'm going to specify how I want to change the values using a long string. That's how recode expects its instructions for how to change the values of a variable. So the double quotation marks indicate the beginning and end of this long string. And then within the string, I need to specify an existing value, a single equal sign, and a new value, and then a semicolon, and continue that process. The existing value Asian is already a string, so I'm using single quotation marks so that R will recognize that those quotation marks are to appear within this longer string enclosed by double quotation marks. And that value is going to change to 1 in my output. And then the semicolon indicates that I'm about to give the instruction for the next value. Black will change to 2, semicolon, white will change to 3. This whole function call will construct a copy of the race variable that has these changes made to it. And I'm going to assign that copy a new name called race2. So if I run that, then race2 has these 1s, 2s, and 3s just like I asked for. And those are the labels of the factor values. You don't have to get into details about that just yet. But it would have worked even if race was a true character vector originally. Race2 would have been a true numeric vector as a result. Another example of a package that might come up in your everyday situations is the foreign package. It can be used to read data files that were created by other statistical software packages. So to illustrate that point, I've included an example data file called spssdata.sav, which is the file extension for the SPSS data format. And that file, which was in the zip file that I emailed out at the beginning of the workshop, contains exactly the same data as this data1 data frame that we've been working with. So I sent you that same data set as a tab separated file, a comma separated file, and an SPSS data file. If I read in the package foreign, I can see that it's currently loaded and it got stuck before the car package. The order here only matters if there are objects with the same name in multiple packages. The first one it reaches will be the one that gets used. That does happen sometimes. There are packages that have functions with the same name, but I didn't get any warning messages when I loaded library, so I know that foreign does not have any functions that already exist in any of these other packages. I'm going to use the read.spss function from the foreign package, and I'm just going to supply 2 arguments. The first argument is the file name of the data set I want to read in, which is in the current working directory, so I don't need to specify a file path. And the second argument is 2.data.frame, which just tells this function that I want, because I assign this the value true, it tells read.spss that I want to read in this data file and treat it as an R data frame object and assign the result to SPSS data, this new arbitrary name I've written out. I got a note about text encoding, which is not important right now. And here is the result. This data frame looks very much like data 1 because it contains the same data set that the tab separated data file contained when we read in data 1. So this worked, and you can use it to access your existing SPSS data sets without having SPSS installed on your computer if you want. And this is the typical first attempt I make to read someone's SPSS data if they send it to me and I'm not in my Syracuse University office because I don't have SPSS installed on my personal computer. Okay, I'm going to make a few recommendations before moving on to talking about data types. There's lots and lots of useful packages out there. I encourage you to explore them and look for ones that accomplish tasks that you find yourself doing on a regular basis. Ones that I have found useful include Psych. So I can load Psych. Oh, here's a good example. There is a function called logit already in the car package. But now I've attached this new package, Psych, and so it has masked the logit function from the car package. That just means if I execute the logit function directly, it is using the version of it that is in the psych namespace rather than the car namespace because psych is the one that I loaded most recently. Most of the time, again, this will not matter for you, and I encourage you not to rely on this when calling functions in R. Instead, I encourage you to try to make sure you're not having multiple objects with the same name um, when possible. But of course, with packages that you want to use, sometimes it's unavoidable because psych and car are both packages that I use very frequently. So I'm almost always going to get this kind of warning. So psych includes a number of useful functions. One that I use, um, I'm trying to type and talk at the same time, doesn't work very well. One that I use a lot is principal. That's not a very good way to illustrate it for you, but if I look at question mark principal, then it will open up the documentation for me. This will perform principal components analysis, and that is in the psych package. So here you can see that in the documentation page, the name of the function is in the upper left corner, and this tells me what package it's in. So this is good. I got the principal function that I wanted, the one in the psych package. Um, if you find documentation for an R function on the internet and you don't have that function, check up here in the curly brackets next to the function name to see if it's in a package that you don't have, and maybe go get that package if you really want to use that function. Um, so that's what I typically use for principal component analysis. Uh, there is a package called ggplot2, um, which I might not have installed on this computer. Nope, I do. And that one is used for plotting. It's widely loved. I don't use it as my main plotting tool, but it does have a lot of really powerful plot types in it. So I do recommend exploring it. And there are two major packages that have really useful functions for regression with nested and random effects. And those are NLME and LME4. And I use both of those. You're welcome to ask me questions about them. If you talk to other R users or read about R online, you will probably start to notice that different fields of study in academia or in business, um, and different people within each of those fields have different assumptions about which packages are normally to be used. And one of my pet peeves is that some people communicate as though certain packages are simply defaults used by everyone. I find this is fairly common among evangelists for the tidyverse set of packages, for them to assume that those packages are just part of what should be referred to as R, and that people who don't use them as part of their primary R experience are sort of oddballs or not using R the way it is normally to be used. But in my experience, that tends to be a pretty narrow view of things. You only have to meet people from a wider variety of fields and a wider variety of job types before you realize that basically no set of packages is standard, and different areas have different packages that are extremely commonly used for them. So I encourage you to learn about and use all kinds of packages, but for the sake of clarity, I encourage you to specify which ones you're using when you communicate about programming in R, rather than assuming that your favorite ones are universal.